Okay, so with 8.6, and we're starting with section 8.6 instead of 8.1, because I want to teach you guys how to graph this, and I'm going to show you a little different method to graph quadratics, okay, than you're probably used to. Okay. Now, the chapter 8 is on quadratic equations, okay, and quadratics are what? You know, x what? X squared functions, right? X squared are called quadratics, okay? And we're going to get to that in just a second, okay? So let's hit our starter questions real fast. So y equals mx plus b is called slope-intercept, correct?
Is the next blank parabola?
When we get there, quit reading ahead. Okay, so now can you guys all graph that? Do we need to do that really? So your intercept is at 0, right? And then you go up 2 and over 1, and then you graph it, so it'll look something like that. Okay. All right. Anyway, so every function makes a shape when we graph it. Now the shape is a picture of all the points that work in the function. Now this chapter we're going to talk about a special type of function called a quadratic function. Okay? And again, quadratics are polynomials that have a squared variable. That's the key there, okay? Is it's x squared, okay? And that's what makes it a quadratic, okay? Now, precisely a quadratic function of the form blah, where f of x equals ax squared plus bx plus c, where a, b, and c are all numbers, okay? And a can't be 0, obviously, because then it wouldn't be a quadratic. Then it would be a line, okay? Now, quadratics are used a lot in mathematics, okay, and in real-world applications. We're going to go over both of those, a lot of those in this chapter. All right, so the basic graph is called what is it, Gertie?
A parabola!
Correct. It is a parabola. Okay. All right, so now we just want to start with graphing here, and then we're going to, and then I'm going to show you probably a better way to graph it. Okay, definitely an easier way. All right, so with basic graphs, okay, right, we just plot some points for x, plug it into the equation, and figure out y, correct? So when you see use an xy table, that's what we're talking about. All right, so if we're going to do the most basic quadratic we can, f of x or y equals x squared. Okay, so if x is -2, what's f of x? What's -2 squared? Yeah, it's 4, right? What's -1 squared? What's 0 squared? What's 1 squared? What's 2 squared? Okay, let's plot those points. So we have -2 and 4. We have -1 and 1, 0 and 0, +1 and 1, +2 and 4. So it's going to look like that. And that is the shape of a parabola. Okay? So, easy enough? Okay with that? Okay, now let's fill out our little box here, and this is going to help us with our graphing. Okay. So the vertex. Now, does everybody know what the vertex is in a quadratic?
The lowest point?
Yeah, if it opens up, it's the minimum. If it opens down, it's the maximum point. So in this case, our vertex is at 0 and 0. Correct. So the basic function, the vertex is at the origin. Okay, now, in order to graph, watch this, okay? So from the vertex now, we're going to go right 1. Now, in this one, if we go right 1, we go up, okay, we also go up 1, correct? But we're going to write this, and the reason for this blank is this. We're going to go up 1 squared. Now, what's 1 squared? What's 1 squared? 1, yeah, so we go up 1, right? Now, again, from the vertex, if we go right 2, how much did we go up? We went up, no, we went up how much? We went up, what was that point? We went right 2 and we went up 4. Or we went up 2 squared. What's 2 squared? 4. Yeah. Okay. Now then we repeat the same pattern on the left side. So we go left 1 and up 1 squared. We go left 2 and up 2 squared, and that will give us our parabola, okay? Now, in this case, the axis of symmetry, okay, can you see the parabolas are, quadratics are symmetric, and this axis of symmetry is in this case, it's the y-axis. Now, one thing that you also will learn as we go about the axis of symmetry always goes through the vertex, and it's always just the x value of your vertex, whatever that is. Okay. All right, and then the parabola opens up. We already talked about this. And the minimum value occurs at the vertex. Okay. All right, so we're going to do some more graphing here. Now, eventually, we want to get to the point where we don't even really need our xy table. Okay. All right, so now we're going to do x squared plus 1. So we've got x and we got y or f of x here. It doesn't matter whether you put y or f of x, I don't care. But we'll use our same points here, -2, -1, 0, 1, and 2. Okay, so if x is -2, what's y, or what's f of x? Okay. What about -1?
2.
What about 0?
1.
1? And 2? 5. Okay. All right, so let's plot those points. So we go -2 and 5. We go -1 and 2. We go 0 and 1. We go 1 and 2. And we go 2 and 5. So what do we do with those? So what did that +1 do to our parabola? It shifted it how? Up 1, right? Just shifted it up 1.
The slope and then mirror it?
Nope, because there's no slope, because quadratics, the slope's always changing,
Oh.
right? So we can't just find the slope. Good question, but unfortunately, no. All right, so let me ask you this now. Okay, so now let's look at our points, okay? So we found our vertex to be at 0 and 1, correct? And then we went right 1 and up 1 squared again to 1 and 2. Then we went right 2 and up 2 squared, or 2 and 5. And then we repeated the pattern on the left, okay? So now what is this, if +1 shifts it up 1, what is -2 going to do?
Take it down.
Shift it down 2. Okay, so where's my vertex?
-2. Was 0 negative?
At 0, -2, correct? Okay, let's plot that point. Oops, missed. Okay, hang on one second. Okay, so now we're going to plot our vertex here at 0, -2. All right, now let's use the rules that we know. So if I go right 1, I go up how much? 1 squared, or I go up here. So what is that point? 1 and -1. Okay, what if I go right 2? How much do I go up? 2 squared, always. So we go up to where? I go up 4, go 1, 1, 2, 3, 4. And coordinates that point then are 2 and 2. Now what if I went right 3? How much would I go up? 3 squared, so I'd go up 9. What if I went right 4? How much would I go up? 4 squared. What if I went right 10? How much would I go up? 10 squared, okay?
Why did you start from 1, -1 when you got to 2?
I didn't start from 1, -1. I started from 0, -2, because that's my vertex. Then I went right 1 and up 1 squared. And then from the vertex, I went right 2 and up 2 squared. Okay, now we're going to repeat the same pattern on the left. So if I go left 1, that puts me at -1. I'm going to go up 1 squared, or to -1. If I go left 2, I go up 2 squared, or to +2. And there is my parabola. All right, so if we add or subtract a number to the back end of our function, okay? If it's plus k, we move the pattern up, k units, and if it's minus k, we use it, or remove it, sorry, down k units. Okay, so we add or subtract something on the outside, that's what we call a vertical shift. It shifts it up if it's plus, if it shifts it down if it's minus. Okay? You all right with that? Cool. Okay, and that is called a vertical change. Okay, now let's do an add and subtract on the inside. So now we're going to do a +1 on the inside.
Did you get new software too?
Yeah, because I can record these now and then post them on my website. So, okay, so now if we get a +1 there, so let's do our XY table here just for this one to see what happens. So okay. So we'll go -2, -1, 0, 1, and 2 again. Okay, so if x is -2, what is y? If I plug -2 in there, I get -2 plus 1 is -1 squared is 1. Good. What about -1?
0.
What about 0?
0.
Eh, it'd be 1, right? What about 1?
2. 4.
4, good. What about 2?
9.
Good, okay. All right, so let's plot those points. So now, just looking at this, where do you think your vertex is? Looking at those points there. Which one do you think is your vertex? Yeah, okay, 0, 1. All right, let's see. Here's the thing. Okay, let's plot 0, 1. Now I also have -1, 0. And I also have -2 and 1. So is 0, 1 my vertex? It is not. I also have 1 and 4. And then I have 2 and 9. So which one is my vertex?
-1, 0.
Yeah, -1, 0. That is our vertex there.
Where is the lowest or highest?
Correct. So now it looks like that. Okay, now let's do let's check our new graphing technique out. Okay. Now the thing with our new technique, you have to know where the vertex is. Okay, so we already know. Now we know our vertex is at -1, 0. Okay, so we start -1, 0. So I go right 1 and up 1 squared. Correct? Or to 0 and 1. I go right 2 and up 2 squared. Or go to. Okay, I go right 1 and up 1 squared.
I don't understand this whole, the up square.
Okay, this is a squared graph, right?
Yeah.
So that's how we're finding new points. So instead of having to go through all this mess of plugging in 1,000 points for x, all we have to do is find our vertex. Once we find our vertex, now we just simply count from that point to get our new points. Right.
You don't graph from 0, 0, you just.
Correct. You graph from the vertex, not from the origin. Good, good, okay? So once we find the vertex, then we go right 1 and up 1 squared. Then I go right 2 from the vertex and I go up 2 squared. Now in this case, because we weren't sure where the vertex was, we ended up going right 3 and we went up how far? How far do we go up? 3 squared, went up 9, or 3 squared, up 2 right there. Okay, then we go right 1, we go left 1 and up 1 squared, and then we would go left 2 and up 2 squared, etc., etc. Left 3 and up 3 squared. Okay.
Was that what quadratics at?
Mm-hmm. When they're in a certain form, and I'm going to show you the form. Actually, no, that's not true. In any form, okay? The key is you got to find the vertex first. Once you find the vertex, then graphing, all you have to do is count. Okay? Now, it gets a little different than this if there's a negative out front or a number out front, but it's a really simple adjustment, and I'll show you that as well as we go. Emma,
So why do you do that? You don't write one up on
to graph it.
Just to find all the, like, the exact.
To find, okay, so in other words, so instead of going through all of this mess,
You want us to do that?
I want you to do this, yeah, because we're going to get, these are extremely simple equations, right? Now, this works for really easy equations. But when I start getting equations like f of x equals -3 times x plus 2 squared minus 4, then plugging x in gets a little more complicated, right? But if we know how to count, this is easy, okay?
And it's always Right one, up one.
squared.
Okay.
Right 2, up 2 squared. Okay? Now, that up is going to change when we throw a negative out in front, but I'm going to show you that. And again, it's really simple. But if you remember that pattern, okay, it's going to make graphing quadratics a piece of cake. So from the vertex, it's right 1, up 1 squared. Right 2, up 2 squared.
So up 4?
Yeah, yeah, up 4.
Over 2, up 4 every single time.
Right.
If,
For the basics, okay? Just get the pattern down. Okay, so, but now let me ask you this, what did that plus 1 do? How did that move our graph?
it moved it to the left.
Moved it to the left one, correct?
It's
See-
all coming
see our
back.
graph?
It's all coming back.
Yeah, I was gonna say, yeah, well, I know if you had me last year, we did all this last year. Okay, so if plus 1 moved us to the left one, guess what this minus 2 inside is
So,
gonna
to
do?
the right.
It's gonna shift it to the right 2.
So
So where's our vertex gonna be then, Josh?
it's going to be 0, 2, 0.
Good, there's our vertex right there. Okay, so we know our vertex is at 2 and 0, good. Now, we don't even have to plug x in anymore because we know how to count this out, right? So I'm going right 1,
Up 1.
and I go up 1. So that point is at, if we have to plot the point, that point is at 3 and 1. I'm gonna go right 2, which will put me at 4,
No, 4.
and I'm gonna go up 4. So that puts me to point 4 and 4. Now, if I go left 1, that puts me at 1. If I go left 1, I go up 1. And if I go left 2, I go up
4.
2 squared, or 4.
Oh my gosh. It's
Done. There we go. Graph is done.
This is too easy.
That's what I like to hear.
This is,
Does this also go over like,
do you look at the next page?
Okay?
Tedious.
does this also go over like squishing it and lightening it?
Yep, we're gonna talk about that in just a second, okay? If we add h to the inside of the other parenthesis there, then we move the pattern to the left.
Left H units.
Left h units. And if it's a minus on the inside, then that is to the right h units. And this is what we call a horizontal change. Or a shift, actually. I like the term, and I'll use the term shift more than I'll use change, okay? So outside is a vertical shift, moves it up and down. Inside is a horizontal shift, left and right. Again, opposite of what you'd think for those, okay? All right, so far so good? Sweet. All right, so now we have y equals negative x squared. Okay, now we're not adding or subtracting anything, so where's our vertex gonna be?
0.
0, 0, okay?
But now we
Now in this case, if I go right 1, instead of going up 1 squared, I'm gonna go
down.
down 1 squared. And why am I going down? Because it's negative. And if I go right 2, I'm gonna go
Down.
down 2 squared. And then the same thing on the left. Left 1, down 1 squared. Left 2, down 2 squared. And there's our graph. So if there's a negative out in front, it's what we call a vertical flip, okay, or reflection about the x-axis. Okay, we just flip it over the x-axis, right? So anytime there's a negative out in front, we flip it. Easy enough, okay? All right, now what if we have a number out in front like that, like this 2? So now this 2 then, so what would a 2 out in front do? Do you remember? It's going to take it and stretch it, right? So it's going to make it skinnier, okay? But let's see what that does, now how we have to adjust our counting thing, which we really don't have to that much. So where is my vertex on y equals 2x squared? Is it the origin still? Vertex is still the origin because we haven't shifted this one at all. So there's my vertex right there. Now when I go right 1, I'm going to go up 1 squared times 2. So I'm going to go up 2. Now when I go right 2, I'm going to go up 2 squared times 2. I go up 8. You got it. Now what if I went right 3? I'm not going to because my graph's not big enough. What if I went right 3? I would go up 3 squared times 2, or 18. Right? Yeah. Okay, but we're not going to do that. So we're going to go, so we go left 1, and up 1 squared times 2, and left 2 and up 2 squared times 2. So you can see that makes our graph skinnier. Okay? We okay with that? Hey, that's just about as hard as we're going to get.
Really?
That's how easy this method is once you get it. It takes a second to get it, but once you get it, it's like, oh my gosh, really? That's it? Yep, that's it. Okay? Okay, now we have a fraction out in front. So it's gonna do what with it, Josh? Make it not skinnier. It's gonna make it wider. So instead of a vertical stretch, we're going to squish it. We're gonna do a vertical squish, so we're gonna make it wider. Okay? So let's do our let's do our graphing technique. So where's our origin?
0, 0.
0, 0, we haven't moved it, right? Haven't shifted it anywhere. Now if I go right 1, I'm gonna go up how much? 1 squared times 1/4. So I'm gonna just go up a fourth. Now what if I go right 2? I go up 2 squared, which is 2 squared is 4. What's 4 times 1/4? What's 4 times 1/4? 1. Right? So we go right 2 and up 1. And then the same thing on the left. Left 1, up a fourth. Left 2, up 1. So you can see how that flattens the graph out. Okay? So, number out in front. Okay? Let's make some rules. Hang on. Okay, so number out in front here. All right? If A, okay, now it's vertically stretched or shrunk, right? It's stretched if A is greater than 1, or it's shrunk if A is between 0 and 1. That's how we determine whether it's a stretch or a shrink. Okay? And if A is negative, we flip it over, right? But those rules still apply. If it's -2, we flip it and we stretch it. If it's -1/4, we flip it and we squish it. Okay?
Flip and squish.
There you go, Gertie. Flipping and squishing. Okay, so just tell me this. What's going to happen
It's just gonna go
to this graph here? It's going to shift it up 2. Okay, what's this graph going to do? Shift it down 1. What about this one? It's going to squish or stretch?
It's gonna stretch.
Stretch it by a factor of 3. And what's this one going to do? It's going to flip it and stretch it by a factor of 2. Okay? Good, good, good. All right, so now what is this minus -3 going to do? Shift it to the right 3. Remember, inside's opposite of what you think. And then what's that +4 going to do? Shift it to the left 4, correct? Okay, so I'm not going to plot all those because I think we get it. Now I want to put everything together though, and now we're going to do some serious graphing. Okay? Okay, so now the key here is to figure out where the vertex is. Okay? Now the vertex always starts at the origin and then it changes as we shift it. Now how does this graph shift? It shifts
To the right.
down 4 and to the
Right.
left 1. Correct? So we go left 1 and down 4. There's our vertex right there. If you want the actual point is -1 and 4. Okay? Now that we have our vertex, we don't need these numbers anymore. They don't matter. The only purpose of those numbers is to move our graph, to shift it, okay? We've now shifted it, we're done with them. Now we go back to our graphing technique, okay? So from the vertex, if I go right 1, how much am I going to go up on this one?
1 squared.
1 squared times 2, or up 2. Correct. No, 1 squared is 1.
Oh, yeah.
So we just go up 2. So we go from -1, -4 to 0 and -2. If we need the points. If you don't need the plot points, don't worry about it. Okay, now what if I go right 2?
Up.
I go up 2 squared times 2, or I go up 8. So I'm at -4, so I go up to +4. So then that point is at 1 and 4. And now we do symmetry the other way. Left 1, up 1 squared times 2. Left 2, up 2 squared times 2. And there's our graph. Okay, so now, yeah, so now we take a long, complicated graph like that, and it is easy to graph,
Duh.
correct?
Yeah.
Okay, as opposed to, okay, let's pick some points for x. Let's pick x is -2, -1, 0, 1, and 2, and plug that in that mess and try and figure it out. Do I think this way is just a shad bit easier? I do believe. See, now we're getting all sorts of crazy. Okay, how are we shifting this one now?
Up to
Left 3 and up, oops, left 3 and up 2. So so now our vertex is at, again, if you need it, the vertex is at -3 and 2. Okay, so now what is that negative out in front going to do? Flip it. What's the 1/2 going to do? Squish it, right? Now again, remember, we don't need these anymore. So I go right 1 and I go down 1 squared times 1/2, or 1/2. So again, if you wanted that point, that would be -2 and 1.5. But if you don't need it, don't worry about it. So what if I go right 2? I go down 2 squared, which is 4, times 1/2. Half of 4? I go down 2. So there I am right there. So now that point would be -1 and 0. And now we just use symmetry. Left 1, down 1/2. Left 2, down 2. And there's our graph.
That was awesome.
I'm trying to make this hard, people. I just can't. It's just way too easy. Okay, now you can graph extremely complicated quadratics with ease and confidence. Okay, so let's kind of tie this together a little bit. So as mentioned earlier, when we graph a linear equation, we like the graph-friendly form, which is y = mx plus b, right? Slope-intercept form, okay? Well, this that we've been working with quadratics is also called the graph-friendly form. And with a quadratic, it is called vertex form. And the reason we call it vertex form is because it gives us our vertex, right? We knew exactly how to shift it to find our new vertex, correct? So the general form of vertex, you can see, is right there. It's f of x equals a times x minus h squared plus k. Okay, so where's the vertex then? At this one, the vertex is at? It's at, actually, since h is negative there, it's at h and k. See, we put minus in the equation, so we don't have to put the vertex at negative h. It's just at h and k. So now the axis of symmetry is always going to be the x value of your vertex. So at x equals h, that's your axis of symmetry. And if you look back at those previous graphs, the axis of symmetry always goes through the vertex, and it's at the x value of the vertex, okay? Now the graph will open up if a is good, a is greater than 0. And open down if a is negative or less than 0. If it opens up, will it have a max or a min? If it opens up, it has a min. Then if it opens down, it has a max. Good. Now the max or min occurs at the vertex. Okay. Now we usually say this. We usually say the max and min is the y value, or in this case is k, and it occurs at h. Okay. And that gives us both points of our vertex. And we'll go over that, and you'll see that's just a specific way of saying it, okay? All right. So let's look at our example now. We're going to graph this. Now we want to not only graph it, but we want to give the vertex, the axis of symmetry, and the max and min value, and where it occurs, okay? Okay, so we're shifting this where?
To the left.
Left 2 and down 1. So where's our vertex now?
-2.
Vertex is at -2, -1. Good. Okay, we've already done that part right there. Now where's our axis of symmetry?
0, -2.
At x equals
-2.
-2, just -2. That's all I have to say. Okay, because it's an axis, right? So this right here is my axis of symmetry. That's done. Okay, now the max or the min. So is this a max or a min? Is it a min? And what is our min? Our min is -1, and it occurs at -2. So our minimum, so when it talks max or min, it's talking the y value. So our minimum's -1, and it occurs at our x value, or at -2, okay? All right, so we've done all that. Now let's just graph it. So from my vertex, I go right 1, and I go up. How much? 1 squared times 3. 1, 2, 3. And we can plot that point if we need to. I go right 2, and I go up. 2 squared times 3, or 4 times 3, or go up 12. Good. So now I'm up here at 11. So those points, again, those points would be 1 and 2, and then 0 and 11. And again, now because we have our axis of symmetry, now we do the same thing on the left side. So we go left 1 and up 3, and left 2 and up 12.
How do you write the minimum again?
Okay, so the minimum is k, and it occurs at h. So right, the minimum is -1 at, that's an at symbol.
What's K?
K is the y coordinate of your vertex, right? Your vertex is at h and k.
Okay.
So the minimum is the y value, and it occurs at the x value. Okay. Yeah, on the back of the second page, you've got just a bunch of graphs, so you can do that for Math Excel. Okay, so let's graph 3/2 x squared. So where's my vertex? Yeah, vertex of the origin, right? 0, 0. We didn't move this anywhere. So right 1 and up, 1 squared times 3/2, where we go to 3/2. Right 2, I go up 2 squared, which is 4. What's 4 times 3/2? Times 3/2. 4 times 3 is 12, over 2 is 6. Good, we go right 2 and up 6.
Wait,
Right, 4 squared, 2 squared is 4.
4 times 3 and a half?
Yeah, so we're doing 2 squared times 3/2. So
No,
2.
the first thought, so 1 squared.
Oh, yeah,
That's-
yeah, so go over, right 1 and up 3/2, or 1.5.
Oh,
Yes, we don't go up 3/2 or anything like that. This isn't rise over run, this isn't a slope, okay?
Yeah.
So yeah, so we just go up 3/2 or 1.5, okay? And then we go right 2 and up 6, and then we use symmetry. Left 1 up 3/2, left 2 up 6. Done. Okay, now where is my minimum? My minimum is 0, and it occurs at 0. Yeah, because we didn't move it anywhere, right? Okay, we starting to get this down? Yeah, not too bad, huh? Okay, so now, am I moving this graph?
Yes.
Which way?
Left.
To the left 4. So where's my vertex now? My vertex is at -4 and 0. Good. Where's my axis of symmetry?
0.
X equals -4. Okay, and is this a min or a max? It's a min. And my min is? What's my y value of my vertex? Min is 0, and it occurs at -4. That's a -4. Fine, I'll try it again. All right, let's graph. So we go right 1, up 1 squared, right 2, up 2 squared, left 1, up 1 squared, left 2, up 2 squared. And we're not timesing by anything, we're not flipping, we're done. We are flipping done.
So we don't have to do like 1 plus 4 squared,
Nope, that's a great thing about it.
because we already moved.
Right, exactly. That's only to move it. Once we've moved it, we're done with that +4. We don't need it anymore. Now we just look at x squared. Yeah, very nice. Very convenient. Okay. Thinking about it. There it goes. Okay. So, yeah, and the reason that I teach you this graphing technique and the reason we're doing this early, so now later on Okay, let's try this again. So the reason I teach you this is so later on in the chapter, okay, you'll be able to use this graphing technique and it'll be a piece of cake instead of plotting points like Math Excel is going to want you to do, okay? All right, so what's going to happen here?
Gonna go to the down,
Up
to-
to.
Up to, and we're going to flip it, right? So where's our new vertex?
0, 2.
Is it 0 and 2? Good. Axis of symmetry?
Isn't it Y?
It's x, it's always x equals.
Okay.
In this case, it's x equals 0, because we didn't move it left or right, so it's our axis of symmetry. And is this a min or a max now? This is a max, and what is my max?
2.
Max is 2, and it occurs at 0. Correct. Okay. All right, now we don't need our plus 2 anymore. So now we plot a point. So we go right 1 and down, 1 squared. Left 1 and down, or left 2, sorry, and down 2 squared. Or right 1, gosh, sorry. Right 1 down 1 squared, right 2 down 2 squared. Left 1 down 1 squared, left 2 down 2 squared. And we can give those points if we need to, correct? I just can't make this harder. It's just too easy, I'm telling you. Okay, so how do we move this?
Gonna go to the right.
Right 2
Down 4.
and down 4. Okay, so there's our vertex. Our vertex is at 2 and negative 4. Okay, now we don't need those two numbers anymore. Okay? So from there, I go right 1 and
Down.
down 1 squared. I go right 2 and I go down 2 squared. Left 1, down 1 squared. Left 2, down 2 squared. Okay, and there's our graph. Now if we want all of our other information, we've got our vertex. Where's our axis of symmetry? At x equals 2. Excellent. And is this a max or a min? And what is my max? Maximum is negative 4, and it occurs at 2. Seriously.
And there'll never be sideways ones because those would be functions.
Correct.
Because the vertical line.
Once we get to 1050, then you'll start flipping parabolas over, but not in this class. All right, so without even graphing now, we can figure stuff out, correct? From this. Okay, so where's my vertex here? Excellent. 1 and negative 10. Good. Axis of symmetry? X equals 1. And is this a min or a max? It is a min, and what is the min? The min is negative 10, and it occurs at 1. Are you kidding me?
That was easy.
Yes, ma'am. Okay. Okay, last problem. It says, write an equation for a function having a graph with the same shape as this, okay, but with a given point as the vertex. Okay, so now we know our vertex is at 1 and 3, so how did we shift that? We shifted it right 1 and up 3, right? So how does that change our equation then?
It'd be x squared minus 1.
Okay, so we get 3 halves. Now it's just x minus 1 squared, not x squared minus 1. And then plus 3. Done.
That's awesome. I feel like I get this.
You should get it, because this is easy stuff.
Why is it negative 1 again? Just because you're shifting it to the right?
Correct. It's minus 1 in there because we shifted it to the right
I
one.
was just
That one
curious
right
why
there.
we read negative 1, but no.
Yep, that's it. Okay. We good?
We're good.
Questions? Signing off.